Okay, so we are going to be talking about the components of a lab plan. So, lab planning is a big thing whenever you are trying to plan an investigation. So, whenever we plan our investigations, you are usually given a guiding question and a material. So, in the case of this lab, our guiding question is what solution makes the best bubble? And so we're going to be testing which of these solutions makes the best bubble. The components that go into a lab plan are you must have a hypothesis. So all a hypothesis is, if you've ever heard it, is an educated guess. So the educated part is according to some research I've done, or according to personal experience, according to blah, 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 I think this will happen. It's usually stated as an if-then statement, but all this statement means is that you think that this is going to happen according to some sort of education that goes behind it, whether that's personal, whether that is research-based, some sort of guess. So in this scenario, again, you would say, I think a solution with dish soap and water would make the best bubble because I have blown bubbles with dish soap and water before. It's some sort of educated guess. So again, this is an educated guess. Where because of some background. So again, whether that be research, personal experience, etc. Because of some sort of background, you think you will get some sort of result. So again, in this case, I might say, I think dish soap and water will make the best bubble, or the biggest bubble, or the longest lasting bubble, whatever your definition of best is. And then materials. So whenever you talk about your materials, it needs to be very explicit on amounts. So include quantities. What materials you will use. So again, in this particular lab, we have a set of materials. So the possible materials available, water, dish soap, I can't spell apparently, water, dish soap, glycerin, corn syrup, pipettes. You get 3 9-ounce cups maximum, a stopwatch, a ruler, and some straws. So these are the available materials. Anytime you're given a guiding question and asked to make a lab plan, you will have available materials to you. So what that means is that you won't be able to use anything outside of these materials, but you can use any combination or any one of these materials. You do not have to use them all. So in this case, I would think, okay, I know that I want to test water and dish soap. So we'll have, we'll say, one solution is going to have water and dish soap, so we'll have water. We'll have dish soap. And I can't spell dish soap apparently. We can test the corn syrup, straws, and then stopwatch. So again, being explicit with details, I know that I'll have, oh, and of course our we're only going to use 2 9-ounce cups in this theoretical plan. So in this situation, I would say, okay, I know that those are 9-ounce cups. Let's say I want to do half and half. So we'll use 6 ounces total of water because I'm going to put 3 ounces in one and 3 ounces in the other. 3 ounces of dish soap, 3 ounces of corn syrup. We're going to use 2 straws, 1 stopwatch, and 2 9-ounce cups. So there's my materials. Again, being very explicit with the thing here. And again, up here, I'm going to say my hypothesis is because I have blown bubbles with dish soap before, I think dish soap and water will make, and in this case, I'm going to say longest lasting. So something that I talked about in class was whenever you figure out what you are going to test, that you need to figure out what you think best means. So in my scenario, I think that best is the longest lasting. Some other students have thought best is the biggest, and so they're going to be looking at measuring it with a ruler. Another student thought that the best was how long it would stay in the air, so basically how long it would float. That definition of best, it's just another variable that y'all can experiment with. So lab plan so far, we've had our hypothesis, we've had our materials. Now, procedures. The thing about procedures is they need to be very detailed. So this is a step-by-step, chronological, so that means in order of which you will do them, chronological instructions. So you want them to be so explicit that if you were to give this lab to someone who had never seen this done before, that they would be able to repeat it just like you have done it. So very, very, very explicit. I'm not going to write out, the procedures that I would make up with this lab because, again, they would be very explicit. I'm talking like pour 3 ounces of water from the faucet in cup 1. Add 3 ounces of Dawn dish soap in cup 1. Place cup 1 to the side. Add 3 ounces of water in cup 2. Add 3 ounces of corn syrup in cup 2. Set cup 2 off to the side. Take 1 straw. I'm talking like explicit, very, very, very clear on what you want to happen. And that's that on procedures. Again, I'm not going to write all of these out. You get the gist, though. You would want somebody to repeat your exact process. And then going on from procedures, there is the data. So all data is the quantifiable information collected from an experiment. So I say quantifiable. All quantifiable means is that it can be, it can have some sort of unit of measurement. So has a unit of measurement. So that can be time, that can be weight, that can be size, that can be quantity, so like the amount of something that can have some sort of numerical or unit of measurement. There is observable, but the thing about observable is it can change depending on the observer. So it is not as solid of evidence. We did our inquiry cube where we looked at patterns and tried to infer what we thought was on the bottom of the cube, depending on what patterns we saw, and that was observable evidence. And so some people looked at patterns a different way. Some people thought differently than others, and therefore their claim on what they thought was at the bottom of the cube was different than others. And that's not bad, but if you're saying my hypothesis is either true or not true, or partially true or partially not true, you're going to want quantifiable data. So in this situation, in my lab, I would say my data, if I'm wanting to see which bubble lasted the longest, I would measure the duration of the bubble, so basically how long it lasted, in seconds. So that right there is my data. Now, there's a couple of things about lab setups, and this is mainly just terminology that helps it make sense. So if you've ever heard of a control, that is a group within a or an experiment that has an expected outcome. Why did I say outside? Sorry. So outcome. So all this means is it's something that you can compare all your results to. Like my control in this situation is going to be the dish soap and water, because I know that I can blow a bubble with dish soap and water. I know that it's going to work, but I also am comparing the dish soap and corn syrup, or the water and corn syrup, to see if that blows a bubble. So I've got some sort of baseline to compare it to, a baseline that I know works and I'll collect data on, but we're testing what we don't know to see if it works and then have that result to compare it to. And again, this is a group. A control isn't a variable that you're controlling. You don't control the outcome. You just know that that group is going to have an outcome, and therefore you can compare results to it. Now, variables are a little bit different. So variables are the components of the data that you will collect. Variables are the components of the lab that either you control or that, I say control, either that you manipulate yourself, or that the results depend on what you manipulate. So there are dependent, and then there are independent variables. So the independent variable is manipulated by experimenter. So all that means is these are the things that I'm going to control. That is, the ounces of water. That is a independent variable. I chose that there was going to be 6 ounces of water used. I chose that there was going to be 3 ounces of dish soap. I chose that there was going to be 3 ounces of corn syrup. I chose the material of the straws, if they were plastic or paper. All of those things are what I manipulate. The dependent changes according to the independent. So the dependent variable in this situation is going to be the duration in seconds. And the duration that the bubble lasts will change according to the solutions that I use. So the solutions themselves, the solutions that I choose, water and dish soap and water and corn syrup, are independent. I chose those, but the duration of the bubble in seconds, the results that I'm going to be checking is going to be different according to the independent variable. So that is part of a lab plan. This is your setup here. So you would have hypothesis, materials, procedures, and then what data that you will collect. So these are all components. Anytime we do a lab plan, these are going to be components that I'm going to be looking for. Again, there was an assignment that went along with this where you did a lab plan for a solution of the best bubble. And on that assignment, I was looking for that you had a hypothesis and that it had some sort of education behind it, that you made sure to be explicit on the materials that you used, procedures, that it was extremely detailed. I could pick up that piece of paper and go in my lab and repeat that lab exactly like you wanted it to be done. And then what data that you were going to collect. So were you going to see how long the bubble would last in seconds? Were you going to measure it in centimeters and decide if it was the biggest bubble? Were you going to set a timer? Were you going to do multiple sets of data and determine if we were looking at multiple sets of data? Were you going to measure multiple things? And that was, required there. And then I asked you to also in your lab plan include what your control was, and then what your variables consisted of. So what was dependent and independent. So that is on lab planning.